Hey, welcome. My name is John Allison. I'm Math Director at Arkansas Ames. I've taught AP Statistics for years, but this year I'm at Arkansas Ames. Anyway, every year when the AP FRQs are released, I sit down and work through them and record the solutions, my solutions. I do this cold. I've not looked at the problems before. I do it so that I can let my students know that we're not perfect, none of us are, and that it's okay to make mistakes and you can still score well even if you do make mistakes. So what I'm going to do right now is I'm going to share my screen and let you see. You'll see this when I open it, but I'm just going to show you the where to find this. I'm going to put the link to the FRQs in the description for the video. Let's see, share screen. I'll tell you what, we're just going to go ahead and switch. You can look at click on the link in the instructions on the video, and that will allow you to um, see the questions. I have not looked at them. I'm about to open them up, but we're not supposed to share in the videos. We're not supposed to share the actual questions. So I'm going to pull this up right now on my screen. You can pull it up on yours. I've just opened the booklet to the 2025 response questions. And the first thing I see is problem number one. If you're looking at it with me, I will tell you, um, I'm going to go back here to the Zoom and I'm going to open up my camera where you can see I'll work this on a piece of paper. Oops, why is it not doing this? There. Oh, by the way, I just scored my 2024 solutions from last year that I did this, and these are my results from last year that I gave myself. 3, 2, 4, 4, 4, 3. So if your students, they should feel comfortable. They don't have to make fours on every question or even threes on every question to get good scores. This would translate to a pretty good score if I did well on the multiple choice, and your students could do well also. So let's go ahead and let's start working this problem for number one. So system manager of an automotive company is interested in comparing gas mileages for cars manufactured in country A and cars manufactured in country B. Manager selected a random sample of 100 cars manufactured in country A and a random sample of 100 cars manufactured in country B. Gas mileages for each sample in miles per gallon are summarized in the box plots below. If you're looking at this, you'll see the box plots. I suggest that you do click on the link and pull up the FRQs so that you can go along with this with me as I work through the solution. Compare the distributions of gas mileage for the sample of cars manufactured in country A and the sample of cars manufactured in country B. So this is going to be 2025 number one, and I'm going to compare the distributions. So I do this with a custom BS acronym. There are other acronyms that you may be able to, you may use, you may prefer. So feel free to do that. But this is center, unusual features, shape, and spread or variability. And the BS means be specific. So when I compare these, I'm going to be very specific. So it's asking me to compare the distributions. I'm going to use comparative language. And I'm going to say the median. So I'm using a box plot of, I'm going to make sure I use context here, median gas mileage for cars from country B is greater than the median gas mileage from country A. And I'm going to label these with the values. That's the be specific part. And in country B is about 32 miles per gallon. And country A is about 18 miles per gallon. That's the center part. Unusual features. I'm going to go ahead and say there is an outlier. in the sample. In country A, car with, this looks like 38 miles per gallon gas mileage. That's the only unusual feature I can determine from there. So then we're going to talk about shape. And I'm going to say here, the distribution of gas mileages from country B. Here's slightly skewed left. Where the distribution from country A here's, I'm going to say more, comparative language again, strongly skewed right. And I'm going to go ahead and comment in this unusual features part that there are no identifiable unusual features in for country B. Now for the spread. Because we have box plots, I can't easily determine standard deviation, but I can determine the IQR. The IQR, interquartile range for country B, again, I'm going to label these with values here in a minute, is larger, let's say greater, than the IQR for country A. And looking at the box plots, I can tell 36 minus 24 is 12. So that's going to be 12 miles per gallon for country B. And for country A, the IQR is 24 minus 16 or 8 miles per gallon. And so that's part A. I've compared the distributions for those two. All right. Part B says for the distribution of gas mileage for the sample of cars manufactured in country A, would you expect the mean to be greater than 18 miles per gallon, less than 18 miles per gallon, or equal to 18 miles per gallon? Justify. Okay, I'm going to do part B here. That was part A, 1A. 1B. In the distribution of gas mileage, country A, I would expect the mean to be greater than 18 miles per gallon, which is the median. Because the distribution is skewed right. I'm going to go ahead and reference that outlier on the upper end. And I'm going to go ahead and say that the value of that at 38 miles per gallon. All right, part C. Well, you couldn't see that, could you? There you go. The manager will create a new box plot with the combined data from the sample of cars manufactured in country A and the sample of cars manufactured in country B. What is the range of the combined data set? Justify your answer. Okay. 1C. And this is going to be part I. The range of the combined data set will be, and this looks like the maximum value should be at 40. The minimum value, and 40 was in country B, the minimum value will be from country A at 14. That's the maximum for both distributions. And this is the minimum for both distributions. And 40 minus 14 is 26 miles per gallon. That'll be the range. And part two, what is the possible value of the median of the combined data set? Justify your answer. All right, we know that both of these countries, the distributions have 100 cars. So there's 200 cars total in each. So let's look at this. That means that for country A, 100 of the cars, our median will be the 100, the average of the 100 and 101st cars. And so there are 50 cars in country A less than or equal to 18. And then there are 50 more cars, 25 in country A and 25 in country B, between 18 and 24. So that means the 100th car will occur around the 100 mark. The 101st car will have to be above 100. So I am going to say, sorry, above 24. The first 100 cars in the combined distribution are going to be the first, second, third quartiles of country A, that's 75 cars, and the first quartile of country B, that's 25 cars. That makes the 100 cars less than or equal to 24. And that means that the 101st car will be somewhere between 24 and 30, because that's the rest of the quartiles, not counting the fourth quartile, not counting the outlier in country A. So I'm going to say that, let's just say 25. So part C2, a possible value for the median of the combined distribution would be 25 miles per gallon. We'll have to justify that because there are 75 cars from country A and 25 from country B. Mile per gallon less than or equal to 24 miles per gallon. 101st car in a combined distribution is between 24 and 30. That's the fourth quartile in country A. And that should do it for question one.